Hello everyone. Today we'll be learning about using chords. So we're going to be learning about 3 different theorems that deal with chords and circles. So if you recall from a few lessons ago, a chord is a segment with endpoints on a circle. And it divides a circle into 2 arcs, major and minor arc. So we see in the second circle, this is an example of a chord because its endpoints are on the circle. And I see that's really dividing the circle into 2 different parts. I see that I have my minor arc right here. And I have major arc. A diameter, on the other hand, as we learned about before, is a special type of chord. It's a chord that goes through the center of the circle. And in other words, a diameter actually divides a circle into 2 semicircles. So I see there's a semicircle here. And a semicircle here. And so we have 3 different theorems that we're going to be talking about today. The first one is the congruent corresponding chords theorem, and that tells us that in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So this goes in both directions. So if I am given that AB, the arc, is congruent to CD, the arc, then I can conclude that AB is equal to CD and vice versa. So for example, if AB, the arc AB was 70 degrees and arc CD was 70 degrees, and let's say I knew that AB was 11, I could therefore say that CD must also be 11. And then we have the perpendicular chord bisector theorem and its converse. And that tells us if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So what does that mean? Here I'm given that EG is perpendicular to FD. And since the diameter then therefore bisects the chord and its arc, what that's really saying is that FH is congruent to HD. And its arc is also congruent. So this arc, FG, is congruent to the arc, GD. And that's because bisect means it's cutting it in half. So this diameter, it's cutting this chord, FD, in half, and it's cutting this arc, FD, in half. And then for its converse, it tells us that if one chord of a circle is a perpendicular bisector of another chord, then the first chord is the diameter. So basically we can go the other direction in that theorem as well.